Hello everyone, my name is Pete Simpson. I'm the Restriction Process Coordinator here at ECHA. I'm very pleased to be speaking to you today as part of ECHA's Safer Chemicals Conference. My talk today is about a case study for a restriction that we're currently preparing on per and polyfluorinated substances, PFAS, in firefighting foams. The outline of my talk today is to start with an overview of why PFAS, these per and polyfluorinated substances, are a hot topic for EU risk management at the moment. Then we're going to talk a little bit about the use of PFAS in firefighting foams. And then I'm going to go into a bit more detail about our current proposal for a restriction on PFAS in firefighting foams, specifically how ECHA has been developing this approach, how it links to other ongoing risk management of PFAS at the moment, this universal PFAS restriction that you may be aware of. I'll talk about the REACH restrictions process in a nutshell, just so that people know what a REACH restriction is all about, and then equally how proposals developed by ECHA or by member states are evaluated before the decision-making phase. So moving on, PFAS is a hot topic for EU risk management. Why are we so interested in PFAS at the moment? So PFAS are a large chemical family comprised of thousands of synthetic chemicals. Across this group, there are diverse and desirable properties for uses, which makes them so popular. For example, they're very thermally stable. Some of them will have excellent surfactant properties. Some of them also will have surface tension modifying properties, which means they're applicable across a range of different industrial, professional and consumer uses. The sectors that use PFAS are widespread, ranging from aerospace, defence, automotive, textiles, leather, carpets, construction products, many household products, electronics, in food processing, medicines, and our particular interest here for this talk, firefighting foams. So what's the concern with PFAS? Why are people interested in them? Why do people want to manage the risks of PFAS? Well, essentially it comes down to the structure, really. PFAS, by definition, contain numerous carbon-fluorine bonds. These bonds are very strong and stable. They're some of the most stable bonds in organic chemistry. And because of this stability, especially when there's a large number of these bonds in a molecule, they're very resistant to biodegradation or degradation abiotic in the environment if they're released there. So they're persistent. Alongside this persistence property, which is of concern of itself in terms of risk assessment, understanding the potential effects of these substances over hundreds of years if they're present in the environment, there are some other properties of concern which add to this persistence concern. The first being that some are highly mobile in the environment because of their solubility, and if they have surfactant properties, they can move about readily between environmental compartments once they've been released. And we know this because the PFAS have been frequently observed to contaminate groundwater or surface water and soils, and also in atmospheric particles, for example, so they can readily move around in the environment once they're released. Some of them can. Some PFAS are known to bioaccumulate, notably some long-chain PFAS, the perfluoroalkyl carboxylic acids and the perfluoroalkyl sulfonic acids. Have been noted to bioaccumulate, and in combination, the persistence around and in combination with bioaccumulation, in combination with other toxic effects, have meant that they've been classified as very persistent or very bioaccumulative, VPVB, or as persistent bioaccumulative and toxic substances, PBT, which is a hazard that would justify risk management where releases aren't minimized. This slide here is just to illustrate the diversity of the different substances that exist within the broader PFAS group. I don't expect you to be looking into this in detail. This is a taxonomy that was put together by the OECD a number of years ago. But perhaps just to note looking forwards when we talk about risk management, that this is really only focused on a small subset of PFAS to date. These are the perfluoroalkyl carboxylic acids and the perfluoroalkyl sulfonic acids that I mentioned, and they appear at the top middle on this taxonomy. So some PFAS have been noted already to have had properties that have resulted in risk management, either in Europe or in some instances on a global level under the Stockholm Convention, the POPs Convention. As I mentioned, this has typically been for the perfluoroalkyl sulfonic acids, examples being PFOS, PFHXS, and the perfluorocarboxylic acids, substances like PFOA and the C9, C14 PFCAs and PFHXA. These are substances that are either subject to or going through the restrictions process in the EU. Alongside restrictions, there are other processes in the EU around chemicals management under REACH that are relevant. The SVHC process is relevant for some PFAS, and some have been through this and have been identified as such, notably GenX and PFHXS, and that was a precursor to its restriction process, this SVHC process. As well as SVHC, a number of other PFAS are ongoing, some sort of process under REACH, either it being substance evaluation, and outside of REACH, we have the harmonised classification process as well to identify certain hazardous properties for PFAS. I haven't listed them all here, but they are available to look at on the CORAP list if you're interested in substance evaluation, or you can look at the classification proposals on the ECHA website, for example. So how's risk management typically done for a PFAS once it reaches the restriction stage? The focus has been typically on a concept called the Arrowhead approach and their precursors. What this means is that an arrowhead is identified, and these are persistent, what's known as terminal degradation products. So once degradation has occurred, this is what's left, nothing else will happen. And these arrowheads have hazardous properties. And if it's PFOA is an example of this, and PFHXS is an example of an arrowhead that have hazardous properties, confirmed hazardous properties, and then the restriction is around this arrowhead. But typically in restrictions in the EU under REACH, as well as the arrowhead, related substances are also subject to the same risk management, and these related substances or precursors are substances which can transform or degrade in the environment to form the arrowhead. So therefore, in a single restriction, say of PFOA or PFHXS, rather than a single substance actually being affected by that restriction, there can be many substances affected by that restriction, as long as they can degrade or transform into the relevant arrowhead. And my next slide here just illustrates some examples of PFHXS related substances. The related substances are shown on the left-hand side of the screen, and they can degrade or transform into PFHXS through various mechanisms, hydrolysis or free radical mediated processes. Not all of the related substances would need to degrade into PFHXS. As shown here at the bottom right-hand side, some other substances can be formed from PFHXS related substances, but as long as it's possible for the arrowhead to be formed, then they would be subject to that arrowhead based restriction. However, although the arrowhead based approach has been implemented successfully for substances like PFOA, for PFHXS, and for these C9, C14 PFCAs, these long chain carboxylic acids, there's been a growing consensus over recent years that it's an inefficient approach if you consider the breadth of the PFAS group, and I showed you the diversity of different structures that fall within PFAS, and it would take many years to apply the arrowhead approach to all of the applicable arrowheads within PFAS. So a group-based approach, a more comprehensive group-based approach has been advocated by various actors over recent years, from academia, for example. Various statements from scientists have been made advocating the risk management of PFAS more broadly. In June 2019, the Council of the European Union had requested the Commission to develop an action plan on a group-based approach to eliminate non-essential uses of PFAS. And more recently, so in June this year, 5 European countries, Denmark, Germany, Norway, Sweden, and the Netherlands, submitted or notified to ECHA's registry of intentions for restriction that they're were planning to submit what we call the universal PFAS restriction in June 2022, which will treat PFAS as a group and across all of the uses, with the exception of firefighting foams. So that use-based, group-based approach is currently being developed by these 5 European countries, and we will see that restriction in June 2022. So given that there's this universal restriction on the horizon, why are we talking about PFAS in firefighting foams? Well, essentially that use has been carved out from that universal PFAS restriction, and ECHA has been asked to look at that one independently. So that's why we're looking at it. So why PFAS in firefighting foams? We mentioned some of these desirable properties already. The property to function as a surfactant, but as a heat-stable surfactant that will form a film over the surface of a burning liquid, suffocating the oxygen away from that flammable liquid, but also preventing the escape of any flammable gases and reducing this risk of reignition after the fire has been put out. These PFAS foams have been used effectively in industrial fires, well, in many fires, but particularly effectively in industrial fires with flammable liquids, which are known technically as Class B fires. So in the EU, according to our market research, around 20,000 tonnes of PFAS containing firefighting foams are sold in the EU each year across a range of different sectors, and you can see these sectors in the pie chart here. It's not equivalent to the amount that's used, as some is disposed without use, but it gives a reasonable indication of the market size for these PFAS containing firefighting foams. Not all of the firefighting foam is PFAS. There's other constituents in those mixtures, of course, but it's equivalent to about 500 tonnes of PFAS sold each year in the EU. The largest customer is the oil and the petrochemical sector, and that is representative of about 60% of that use. And then after this, there are municipal fire brigades, some marine applications, airports, military uses, for example, smaller uses. It's worthy of note that the majority of these sectors have substituted PFAS firefighting foams in some of the uses. Typically, this is training or testing, so they are only really used now when there is a real fire that needs to be addressed. When it comes to alternatives, these have all been adopted in many sectors, as I said, particularly for uses around training and testing. The efficacy testing around firefighting foams is obviously taking place using the alternative F-free foams, although typically we understand that this is mainly on small-scale standard testing rigs, and then with a limited number of flammable liquids as the test materials. Therefore, this performance testing against real-life contexts with very large tank fires is not yet completed, and it's not yet completed for all of the possible flammable liquids where these foams may be called into use against. Equally important, according to our analysis, is not just the foam itself, the composition of the foam, but the actual system, and you can see the sort of the nozzles being used here with foams is equally important as the foam itself, and there may be tweaks required for some of these F-free foams compared to the PFAS containing foams, and also the methodology that's used, so whether or not it's a high pressure foam application or a more passive application of foam. It all factors into how effective that foam can be when it's used in practice. Before getting into our work a bit more about how we put together each restriction for firefighting foams, I just wanted to pause just for a minute to talk about REACH restriction in a nutshell, just so that everyone has a good understanding of what REACH restriction is all about. Essentially, within the REACH regime, it's a safety net. It's there to address any unacceptable union-wide risks for people or the environment where these risks have not been successfully addressed by other REACH processes, such as registration or evaluation or authorization, or other community legislation. Where other legislation is not quite fit for purpose, a restriction can come in and mop up any risks that have been identified. It's a very flexible measure. It can ban the manufacture, placing on the market, or the use of a substance by itself in a mixture or in an article. Or alternatively, a restriction can set out specific conditions for placing on the market or use. So, for example, specific risk management measures that need to be in place for use, or specific labelling requirements that need to be in place before placing on the market, for example. As I mentioned, it can be applied to any substance on its own in a mixture or an article. Importantly, the substance doesn't have to be registered under REACH, so a restriction can apply to polymers, for example. Where necessary, it could apply to medicines, it can apply to cosmetics, it can apply to plant protection products. What's useful and interesting to know as well is the substance doesn't have to be classified as such with the typical classification under CLP, so it doesn't have to be PBT or VPVB. All that's necessary is that for a risk to be demonstrated, and this can be against one of the non-traditional hazard criteria, for example. So a case-by-case risk assessment approach justifying a particular restriction on the basis of a case-by-case rate, a risk can be made. There's no minimum tonnages associated with restriction, as they are with registration, for example. And it's, of course, a harmonising measure across the union, so the same requirements would apply in the whole of the EEA from the entry into force of a particular restriction. So now getting into the restriction case study here on firefighting foams. What's the background? ECHA and the Commission at least have been working on this proposal for a number of years. There were some preliminary studies funded in 2019 and 2020 on the use of PFAS in firefighting foams, and specifically an analysis of alternatives. After these studies had completed in July 2020, the Commission formally requested ECHA to prepare a restriction proposal for all PFAS in firefighting foams. And as part of this request, it was specifically noted to cooperate with these 5 authorities preparing this universal PFAS restriction. And it's worth noting that this action for ECHA to work on all PFAS in firefighting foams was an action from the recent Chemical Strategy for Sustainability. Alongside our development work has been another restriction that's been proposed by Germany on PFHXA and evaluated in ECHA's scientific committees. Firefighting foams was one of the uses assessed as part of this restriction, and PFHXA and related substances are known to be used in firefighting foams. So it's obviously very important to monitor how this opinion making went and to learn lessons from that, which we've been doing. There have been a number of complexities with that opinion making, and it's due to complete in December 2021, but we've been monitoring this one very, very closely. So there will be a scope to this restriction. As I mentioned, it's all PFAS, and the rationale will be that we will mirror the grouping rationale being developed by the 5 European countries developing this universal PFAS restriction. The approach here is listed on the slide. It's also available in the RMOA conclusion that was recently published by the 5 authorities, and essentially it's fluorinated substances that contain at least one aliphatic carbon atom that is both saturated and fully fluorinated. In practice, it can be molecules that can contain a single CF2 moiety or a single CF3 moiety. The idea for having such a broad scope is to avoid any potential for regrettable substitution or regrettable development using PFAS type technologies in firefighting foams. And as I mentioned, this grouping will be underpinned by a case by case risk assessment, hazard assessment. We've seen these similarly recently in restrictions for microplastics, for example, that developed a case-by-case approach for regulating microplastics under restriction, but also for PFHXA, a case-by-case risk assessment approach. As part of our work, we always assess different options for a restriction. Our role is to present information to the decision maker to allow them to come to an informed decision about a restriction. So we're looking at different restriction options, and we consider how effective they are at reducing the risks, how practical they are to implement, to enforce, and how easy they would be to monitor in terms of their effectiveness in the future. So we've developed 5 restriction scenarios as part of our work, with some sub-scenarios around lengths of transitional periods that we're assessing against these criteria for effectiveness, practicality and monitorability. One overarching consideration when developing these scenarios was that the fire safety shouldn't be compromised, so there should always be effective foams available on the market to deal with large tank fires. But they do differ somewhat in how the restrictions are put together. As our work as a dossier submitter, we would typically identify a preferred option for restriction for the committees to evaluate, but these discarded options are also assessed. They're also evaluated by RAC and SEC, and one of these could be preferred by the decision maker. So the slide here goes into a bit more detail about the restriction options that we're looking at. I won't go into detail here, but you can see already that they vary a little bit in terms of whether or not they're just on placing on the market and they would allow some existing stocks to be used, or whether or not they would also be restrictions on the use of firefighting foams with different transitional periods proposed for different sectors, depending on the availability of alternatives and how quickly they could be transitioned to in certain sectors. We're also looking at whether or not exports should be banned from the EU, the impacts of that. And we're also looking at 1 or 2 other more complicated restriction options that would involve potential mechanisms for derogations from the restriction for Seveso sites, for example, or sites involved in defence that may have very specific requirements for firefighting. We're also looking at about whether or not a wholly just risk management based approach to regulating the use of PFAS at sites might be appropriate for addressing the risks. And this one particularly became apparent because of the opinion making on the PFHXA restriction proposal. And that's why we've gone into detail at looking at restriction option 5. When it comes to the emissions assessment, we are adopting what is typically called the PBTV-PVB approach, where we're only looking at emissions to the environment rather than exposure in different compartments. We're looking at model PFASs and their fate and behaviour in the environment to model this. And we've looked at emissions under each of these restriction options with various different transitional periods considered, but adopting the releases that can happen at different life cycle stages. So the manufacture stage, the use phase, if there is one, and the disposal phase, for example. And what we see here, although these are just illustrative examples at the moment, is that the different restriction options have different profiles in terms of how quickly they can reduce the releases to the environment. The difference here between restriction option 1 and restriction 2 is basically because restriction 1 would allow stocks to be used until they expire, where restriction option 2 actually imposes transitional periods of where they need to be phased out. The large releases at the start are associated with an obligation to minimise releases to the environment that we apply in each of these restriction options. So alongside the risk assessment, when ECHA is preparing a restriction proposal, we also would look at an impact assessment, a socioeconomic analysis in terms of what each of these restriction options would mean to society if they are implemented. These can be broken down into costs and benefits to actors in society. And we look at various different cost elements when it comes to doing that impact assessment. I won't go into the detail here, but it's quite an extensive list of impacts that we look at. Some are relevant only in specific of the restriction options that we look at. And the approach to impact assessment here is very much looking back at SEAC's PBT PVP approach, as I said, and the proportionality of the proposal is underpinned with these estimates of cost effectiveness. And this comes down to whether the cost of preventing the releases of a kilogram of emissions. And this is typically the approach where it's difficult to value the environmental benefits of regulation. So alongside the cost effectiveness, other qualitative elements will also be discussed, such as persistency and mobility. And we can look at also remediation costs around PFAS contamination of groundwaters, and if these remediation costs would be avoided in the future, these can be taken into account as part of the impact assessment. And finally, I'll just finish with one slide on how restriction proposals are evaluated after they're submitted. I mentioned, I think, a couple of times already in passing, the ECHA scientific committees for risk assessment and socioeconomic analysis. They're both tasked with evaluating the proposals for a restriction that are submitted. Alongside their evaluation is a 6-month consultation of interested parties, where views from stakeholders will be taken into account as part of this evaluation. The different committees take different angles when it comes to evaluating the proposals. The RAC clearly tend to look more at risk-based elements of the proposal, and the SEAC will be looking at the impact assessment, essentially just making sure the analysis of the dossier submitter makes sense. The evaluation is documented into an opinion, and then the opinions are sent to the Commission, where they are looked at by the Commission and the Member States in the REACH committee, where they're deciding on the implementation of a restriction. And alongside this, there's scrutiny by the Council and by the European Parliament as well. So thank you very much. Very much enjoyed talking to you today. I'll now be available in the Q&A session. I very much look forward to hearing your questions, and I hope I can answer them. Thank you very much. Bye. Good afternoon, everybody, or good morning, depending on where you are in the world. Hello again, my name's Pete Simpson, and I'm here to answer some of the questions that you've been posing in the chat during the presentation. I'm being assisted by a number of my colleagues who have already been replying to some of your questions in the chat, and are also helping me to identify any particularly crucial questions to make sure that I answer those and they're not missed. We only have a relatively short period, so I will make a start with some of the questions that we've got in the right hand side, and see if I can answer them. If I don't get round to answering all of your questions, please do feel free to submit these questions via the contact forms on ECHA's website, and they will in due course receive an answer. But I'll try and get through most of them as much as possible today anyway. The first question that I thought I would answer, this was posted by an anonymous user about 2 hours ago, and they raised the point that PFAS uses are not restricted to firefighting foams, and knowledge of other uses of PFAS exists, and what are plans to assess all of these other uses, including unknown uses of PFAS, and what about effects on innovation alternatives. So I mentioned this a bit in the presentation. This work that ECHA is doing on firefighting foams and PFAS is very much complementary to other restriction work which is going on at the moment, what is sometimes referred to as the Universal PFAS Restriction Project, which is being undertaken by the Netherlands, Germany, Sweden, Denmark and Norway. They are looking at all of the other non-firefighting foam uses of PFAS within the context of whether or not there should be a restriction on those PFAS in all but essential uses. And I mentioned that they'd notified to ECHA that they are preparing this restriction and that it would be submitted in the summer of next year, 2022. I said June in the presentation, but actually it's July that we would be expecting this proposal to come. There is actually an ongoing consultation on that process at the moment that you can find on the Bauer website. I actually noticed that one of the other questions in the Q&A was referring to this ongoing consultation on the universal PFAS restriction. So if you are potentially affected by that and you'd like your impacts to be taken into account in this work by the 5 member states, then there is an opportunity prior to submission to get your information across. Okay. Another question here is from Juliana Beck. She asked, is ECHA aware that the current restriction proposal also affects small molecules with one CF3 group, which do not exhibit, in inverted commas, PFAS properties? Yes, we're aware that we have a broad scope. We were invited or requested by the European Commission to prepare a restriction proposal on all PFAS. So this is the scope of our restriction proposal in firefighting foams. Of course, we know that not all PFAS are used in firefighting foams, but the restriction is designed as such to avoid any potentially regrettable innovation or substitution outside of perhaps the traditional PFAS that have been used in firefighting foams in the past. So the scope is generic. It will be based on a chemical structure, and the scope will not be defined with a list of CAS numbers. I know this was another question that was mentioned. In the past, ECHA has, to support stakeholders, published indicative lists of CAS numbers which are affected by particular restrictions, but these are not definitive lists, and it's very much the duty of industry to determine whether or not a particular substance is within the scope of a restriction or not, irrespective of CAS. And typically this is based on the chemical structure. So PFOA, for example, that existing restriction doesn't have a list of CAS numbers, but it can affect a wide variety of substances because of the chemical structure which is restricted there. Okay, let me move forward and see if there's other questions. There was a question about developing alternatives or testing of efficacy. Answered your question there. And then one of the most popular questions that's been voted for was by Cynthia Bennett. This was half an hour ago, and she asked toxic also being considered for bans. This is a really important question. What I would say is that there have been concerns raised generally about the whole PFAS class of substances and their potential effects on the environment. Restriction is a safety net approach, as I mentioned, and it's possible to look at non-conventional hazards within restriction. What I can say is that there's a case-by-case approach to risk assessment that has been developed for this project that is looking at common properties of PFAS across the class and these common properties and their influence on the risk as such, and that's supported with the presence of what are other indicator properties of concern that some PFAS have that some don't, like mobility, for example, bioaccumulation, toxicity, and as on a whole, do these properties of PFAS as such warrant a risk management on a class level? This is the rationale that's being developed for this particular proposal, also for the universal restriction, and this will be subject to the evaluation in the RAC after it's submitted, where very much the evidence for the strength of this particular paradigm will be explored, and whether or not there is this justification for a class-based restriction proposal. I think it's important to recognise that it's acknowledged that PFAS are useful in society and are prevalent in many important uses, and it be, as we've discussed in our firefighting foams work here, whether or not there would be argumentation for derogations in certain uses for certain periods of time in order to ensure that those essential functions remain there for society. I think I have time just for one more question, and I'm just looking to see if there's any new ones that have come in. So there's a question from Maria Jose Jimito Cortez. Has ECHA expire, for example, via incineration? Yes, we're aware of this. The appropriate disposal is something that we are looking at in the impact assessment, but also when I mentioned the different risk management options that we're looking at, one of those options is with respect to whether risk management options at sites may well be effective enough to allow continued use of PFAS in firefighting foams. And this very much looks at whether or not spent firefighting waters can be appropriately treated and the technologies around that, and whether or not that's sufficient risk management to allow those uses to continue. So I'm just about out of time now. Very sorry that I haven't been able to get to all of your questions. If you would very much like an answer to your question, website. But apart from that, very much enjoyed talking to you again. Please look forward to the submission of our firefighting foams proposal, which will be in January 2022.